Greetings, everyone, and welcome to this lesson on vectors. We're going to be considering this particular problem, and notice what the problem says. A, it says the vector OX and OY are position vectors relative to the origin. Now, when they say that these vectors are position vectors relative to the origin, they basically mean that these vectors, their, 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 their initial point, right, or their initial point is at the origin. For example, notice the vector OX. So this is the vector OX, right? And notice that its initial point is at the origin. The same thing for um, for OY. Notice OY, the vector OY. Notice that its initial point is at the origin. So this is the tail and this is the head. So its tail is at the origin, right? So both vectors, once they call them position vectors, their tails or their initial points is at the origin or at the point 0, 0. And so we have these position vectors, OX and OY, and they are position vectors relative to the origin. And they say given the points X, given the points X, which the coordinate for this point X is 13 and -9, and given the point Y and the coordinates for this point is -7 and 24. So they're saying this is the information that we're giving you. Now we want you to simply write what OX is as a column vector and write what OY is as a column vector. Now they give us the point for X, right? They give us the point for X. And the point, or I should say the coordinates for X rather. So they give us the coordinates of X, and the coordinates of X is 13, comma, -9. Okay? So the X value is 13 and the Y value is -9. And so they give us this point, and notice at this point we could look at it as like it's horizontal, right? Think of it like that. It's horizontal. What I mean is that it is its orientation is horizontal. Now, what if we take the same point and we shift its orientation? So we shift it such that its orientation is not horizontal but it's vertical, right? So we're gonna shift this point from looking at as a horizontal orientation to a vertical orientation. And that's basically what they're saying when they say write OX as a column vector. They're basically saying, hey, change this orientation from a horizontal orientation to a vertical orientation. So how would we do that, right? So answer for AI, right? So for AI, we want to take this column vector. I'm sorry, we want to take this point and change its orientation. And so OX is going to be still keeping the 13 and the -9. So OX is going to be, I'm going to put the 13 on top, right? Put the 13 on top. And what do you think I'm going to put at the bottom? Yes, I'm going to put the -9 at the bottom. Okay, so that is the answer for OX. OX is the same 13 -9, but notice we just shift the orientation from being horizontal side to side to being vertical up and down, right? So since we know what OX is, right, 13 and -9, what do you think OY would be, right? OY would be. Now remember, all we're doing is shifting the orientation of this point, okay? So let's look at the point. So this is the point X. This is the point X. And let me use a different color. Let's look at the point Y. Now the point Y is -7 and 24. Okay. And notice that its orientation of how we write this, it's horizontal. All right. So it's like this. Okay. But now when we write it as a column vector, we want to write it as a column, right? Right. That's you can understand its suggestion right there. We want to write it as a column, all right? So the orientation of this one is more like a row. They say, no, we want you to shift this orientation, change it to more of a column, and so you're going to write it like this with this particular orientation. And so OY, let me change the color with this. So OY, let's write it in this baby blue color. So OY, therefore, so OY is going to be equal to, remember, we keep the same numbers, all right? It's going to be equal to -7 on top, right? 24 at the bottom, right? And so look at that. We have completed AI. So we should be able to get our 2 points, right? So OX is written as a column vector is 13, -9, and OY written as a column vector is -7, 24, written in this form. And so that's how we would do AI. So okay, since we know what OX is and what OY is, let us consider question AII. So they're saying, listen, express XY as a column vector. All right. So how are we going to express XY as a column vector? So let me erase this. So we have XY. So XY. So in fact, let's use black here. So XY is a vector. Okay. All right. XY is a vector. And they're saying, hey, listen, express XY as a column vector. All right. So the question is, how does XY look, right? We know we have notice this graph, and this graph shows us, hey, that OX, the vector OX, starts from the origin and goes to the point X. That's the vector OX. And the vector OY starts at the origin and goes to the point Y. That's the vector OY right here. But what is the vector XY? Well, the vector XY would start at X and end at Y. So this red line with the arrow is the vector XY. So let's label this, right? So this right here is the vector XY, right? That's the vector XY right there. So they're saying, hey, listen, we want you to write this as a column vector. Right now, you have it represented in the diagram. Sure, that's nice. But we want you to represent this as a column vector. How would you do this? Well, you would do it like this. So to get, in order for us to get from X to Y, what must we do, right? Which pathway must we travel? Notice, if you look, in order to get, sure, we could go from X directly to Y, but let's not do that. Let us go in the following path. So we're going to go, in order to get to XY, we must go what? From X to O, right? And then from O to Y. Again, in order to get from X to Y, we must go what? We must start at X, go to O, and then from O, we go to Y. All right? And so let's represent that, right? So again, let's remember that in order to get XY, we must start where? We must start at X, right? Then go to O, right? And then, sorry, let's write that better than that. Again, we must start at X, go to O, and then when we reach at O, we must go from O to Y. Okay, from O to Y. Okay, and that's how we're gonna get the vector XY. Now, let us rewrite XO. All right, let's rewrite XO. What XO really means, all right? So let's see. Let's see. So we know if I were to tell you, hey, listen, draw me the vector OX. If I say, hey, please draw me the vector OX. Well, in order for you to draw me the vector OX, it's represented right here. The vector OX would look like this. That's how the vector OX would be, right? With O as its initial point and X as its final point, right? So that's the vector OX. Now, if I say, listen, draw me, right? Draw me the vector XO, right? Draw me the vector XO, XO. Draw me the vector XO. Well, the vector XO would be the same thing, but we're going to start at X, right? Start at X and end at O. Okay, sorry, they're supposed to be the same thing. Basically the same thing, but we're just starting at different point. And so we would start at X, right? Just like our now, and end at O. So our direction would change, right? Same magnitude, right? Same size, right? But we're just starting and ending at different points. So the vector XO is XO. Okay, XO. So we have these two vectors, OX, which starts at O and ends at X, and then we have the vector XO, which starts at X and ends at O. Now, what if I say, okay, all right, what is negative, right, OX? What is negative OX? How would you draw negative OX, right? How would you draw negative OX, the vector negative OX? Well, if we have a vector, say we have the vector A heading in this direction, so we have the vector A heading in this direction, right? Then we say, in general, that a vector heading in the opposite direction of A, we call that negative A, right? So if we have the vector A heading in this direction, negative A would be the vector that has the same size, but just in the opposite direction. And so with that in mind, if we know that OX is this way, right? OX is from O to X, right? And it's heading in this direction. Let's make it clear. So OX is heading in this direction from O to X. Then negative OX would be the same vector, but just heading in the opposite direction. And so let's make a note of that. So negative OX would be the same OX, but heading in the opposite direction. So let's do that. So again, the vector with the same magnitude, the same size as OX, but just heading in the opposite direction of OX. So that would be this. Oh gee, let's let's let us write it properly. So there we go. And so these vectors supposed to have the same size. And again, we start, so again, this is O and this is X. So what I'm trying to say is that the vector negative OX, again, the vector negative OX would be the same thing as the vector OX, but just heading in the opposite direction. Okay? Again, remember A heading in one direction, negative A heading in the opposite direction. But you may say, Isaac, look at this, look at this, look at this, look at this. These two, right, these two are the exact same vectors. Look at that. So XO is the same vector as negative OX. Look at that. These two are the same vectors. I call them by different names, but they are the same vectors. And so what I did that because I want you to know that XO, right? Look at this. XO, the vector XO is really negative OX in disguise, right? The vector the vector XO is really negative OX in disguise. And so that means when we go back to this, right? So again, XO really is negative OX. And so when we go back to this, if we want to write XO, then we could write a different, hey, we don't have the right XO, right? We could just write, negative OX, negative OX. Awesome. And now we're gonna plus it by what? OY. Okay, OY. And so that being said, what is OX and what is OY? Remember, initially we found those values for AI. For AI, notice we have OX. Remember from the previous question that we did, we saw that OX is actually equal to what? 13 and negative 9. So that's 13 and negative 9. And we saw that OY, the vector OY, is equal to negative 7 and 24. Okay? Negative 7 and 24. And so what is this saying? This is saying, hey, listen, OX, the vector OX is 13, negative 9, and OY is negative 7, 4, 24. And so that means we can take OX, right, and plug it into right here. Okay? And we can take OY and replace it with this, right? And so let's do that. So we have, it's going to be equal to, right? We still keep the negative sign, right? And it's going to be negative what? Negative 13, right? Negative 9. So, I should say rather, the negative is also front, and we have 13 and negative 9 in the brackets here. It's going to be plus, what is OY? Well, OY is simply what? OY is negative 7 and 24. Okay, OY is negative 7 and 24. Okay, good. Now, let us consider, notice that we have this negative sign up front, but you could think of this as negative 1, right? And so what is negative 1 multiplied by 13? Well, negative 1 multiplied by 13 is going to be equal to, negative 13. Okay, it's going to be equal to negative 13. And negative 1 multiplied by negative 9 is going to be positive 9. And so this quantity is actually equal to the quantity at the bottom. So what we do, we multiply the negative 1 by these two entries, by the 13 and by the negative 9. And so now let's bring down our negative 7 and 24. Let's bring that down. And so we have negative 7 and 24. Okay, good. Now, all we have to do now is add these two vectors. Now, how do you add vectors? Well, you add them by corresponding entries. So what that means is that we're going to take the negative 13 and add it to negative 7. And then we're going to take 9 and add it to 24. And so let's do that. Right? What is negative 13 plus negative 7? So let's say I owed you $13 and I owed you $7. How much I owe you in total? Well, if I owe you $13 and I owe you $7, then that means in total I owe you $20. Right? So I owe you $20. And because I owe you $20, it's a negative 20. Now what about 9 and 24? Well, 9 plus 24, let's perform our addition. 24 plus 9. What is 24 plus 9? So 9 plus 4 is 9, 10, 11, 12, 13. So that's 3 at the bottom and 1 on top. And 2 plus 1 is indeed what? 3. And so the bottom entry would be 33. So xy, right? And so we could say thus, right? thus, thus xy, the vector xy is actually equal to negative 20 and 33. Okay, and this is how you would find the vector xy. Okay, so we're almost done. We're almost done. So we have considered AI, we have considered AII. Let's consider finally AII. So let me erase. So here in AII or AIII, they ask us, they say calculate the magnitude of OY. Calculate the magnitude of OY. All right. Now, when they say magnitude basically is another word for size, right? Magnitude is another word for size. So they're saying, hey, listen, how big is OY? How big is that vector? If we go here, and we can see clearly what OY is. OY is this vector starting from the origin and going to the point Y. OY is this vector. And they're saying, well, how big or how long or what is the size of this vector OY or what is its magnitude, right? And so that is what they want us to calculate. How can we find the magnitude of OY? In general, if we have a vector, say we have the vector x, right? So we have this vector x, and vector x, we write it as a column vector, and say it has a top entry, which is, we're just going to call it, it could be any number, right? We're going to call it m, right? And let's say it has a bottom entry, we're going to call it n, right? So if we have this vector, it has a top entry of m, a bottom entry of n, right? And m and n just stand for any number, right? These could be any number. So then this means that in order for us to find the magnitude of x, the vector x, in order for us to find the magnitude of the vector x, notice how we will do it. What we'll do is we'll take the first entry, which is m, and we're going to square that entry. What that means is we're going to say m times m. And then we're gonna once we finish squaring that, we're gonna add that to n squared. N squared. Okay? N squared. So we have m squared, which is m times m, n squared, which is n times n. And so we have these two values, then we're gonna add them together. And then we're gonna take the square root or perform the square root operation on this particular value. So again, square the m, square the n, add them, and perform the square root operation. Okay, so that means since we have the vector OX, we have to take its top entry, square it, take its bottom entry, square it, add them, and take the square root. And so let us do that. So recall, right? Recall or remember that the vector OY, is equal to what? Vector OY is equal to -7 and 24. -7 and 24. And so if we want to find the magnitude of the vector OY, the magnitude of this vector OY, then that would be equal to, we're going to take the top entry, which is the -7, right? We're going to take the top entry, which is -7, and we're going to say -7 squared, which basically means we're going to say -7 times -7, and then we're going to add it to what? 24, which is the bottom entry, 24 squared, okay? And then we have to perform the square root operation, or take the square root. What is -7 squared? Well, -7 squared is indeed 49. You can use a calculator to find that out. What is 24 squared? What is 24 squared? Now, I don't know that out of my head, but let's use a calculator to figure that out. So let's keep this. Let's go on the online calculator. So let's say calculator, the site to go on. So notice we're trying to figure out 24, trying to figure out 24. Sorry, my apologies for this. Trying to figure out 24. Sorry for the add. So trying to figure out 24 squared. 24 squared is indeed 576. That's basically, remember we said, that's basically 24 times 24, which is the same 576. And so that means that, let's go back to this. 24 squared is indeed what? 576. 576. And remember, or I should say, do not forget to include the square root again. But what is 576 added to 49? Let's go back to the calculator. 576 added to 49. And note that it will be 576 added to, or if we want to put it this way, 49 plus 576 is going to be equal to 625. 625. So that means that, let's go here, that what we put here at the bottom is still keep the square root sign, but it's 49 plus 576, which is equal to 625. But what is the square root of 625? What is the square root of 625? Indeed, the square root of, and when we say what is the square root of 625, what do we mean? We mean what number, right? What number I could use, say A, that I could use to multiply it by itself, right? And I get 625. That's what that basically is asking you, right? It's saying, hey, what number, right? If I multiply it by itself, I'm going to get 625. Now, clearly, certain numbers ain't going to work. We can't say 2 because 2 times 2 is 4, and it's not 625. 4 times, if you say 3 times 3, if you say A is 3, 3 times 3 is not 625. That's 9. 4 times 4 is not going to work because 4 times 4 is 16. So what number is it? When I multiply it by itself, it gives me 625. What number is that? Now the number is actually 25. And how do we know that? Because notice, let's go to the online calculator. And of course, you can use the calculator, a scientific calculator. In the BGCSE exam, scientific calculators are permitted. And so let's take the square root of 625. And we note that the square root of 625 is indeed 25. And so what that means is that if we say 25 times 25, we get 625. So therefore, let's go back to this. Therefore, the magnitude of OY is 25. So that brings us to the end of this lesson. We have completed question AI, question AII, and question AIII. Hopefully you understood this lesson. Thank you for your time and attention.